Yeah, class job let's begin class. And first I just like roll call, okay? Roll call. Company. Shen Yang. Oh, we look at the progress. And the Chen Dawei here, and the Shen Jia here, and the Shen Fujiang, and the Chen Wenqi, Wang Zhewen.
Attuale non cambia il circa, ninja siamo in decidere non fare desati.
Okay. Okay, yeah, this is the homework. Now we will go to chapter 2. Yeah, this is my email address. If you submit the field, you can send to this email. Okay, this email. Oh wait. Oh wait. Oh, it's not working. Yeah, it's okay. Yeah, and chapter 2, we are to introduce the basis of structural design, some basic concept, also to know some material character in this chapter 2. Yeah, first, let's talk about the action. The actions. Here we need to know for we to construct a building or to design buildings, we need to divide, right? Some of which is the action, of which is the here is just to divide something, divide, and know the action or the resistance. And if the resistance, because we can roughly accept that if the resistance larger than the action than the load, that means the structure is safe. Right? We have the basic or the roughly idea about the design structure, something like that. But here, for we here to just to divide the action of which the action it is, and name it like the direct action means that load directly act on the building, on the structure. Yeah. Look at this bridge, right? Bridge vehicles pass through the bridge. Of course, that definitely a direct act of the bridge. And for indirect action, look at here, these pictures, this settlement right, of building. Why happened or how it affects the structure? They do not touch, right? The sun load, they do not touch the building, but we found the sediment. Or just like earthquake. Earthquake, we use we know this is the earth. Some earthquake, something, some wrong happened at here. Earthquake comes, right? building is here, it affects the buildings. For this type, for this load transfer that we see, these things do not touch the buildings. So we name that this action is the indirect action. Okay? And another is the temperature. Temperature, like for a building in summer or on the sun, right? Sun, the temperature is really high. For material, it will expansion. And for the winter, right? Winter, there is a snow on the building surface, so it will be small. So for there is a deformation, right? Happened on the building. For this type of the load, temperature, we also think it as a indirect action. Okay. For moisture, moisture is about water, right? Water that on the atmosphere. Yeah. So here we can roughly to regard that load directly touch the building, to act building, like people move on the slab, the people, the life load. We name the people, this is type of the life load, they direct act on the slab, so it's the direct action, right? Direct action. So here is we route to divide, to classify action. Another method to classify action, we also name the permanent action. In permanent action, we use the symbol G to represent. And another is a variable action Q, and accidental action with the A. Yeah, for the symbols, it's okay. Sometimes we can use this, but we generally to use these symbols to represent the meaning of the permanent load, the variable action, accident action. It doesn't matter. Maybe using some different versions book, textbook, they use another symbol. It's okay. It's okay. But for my class, I will sometimes, I will use these symbols to represent for permanent load or permanent action. Permanent load, permanent action. These actions have the character that for actions do not vary with the time, right? It's permanent. What's the meaning of the permanent? First, like always be that. You do not change. Like for desk, for furniture, or for the chair, they had the density, right? They had the fixed the value, so they had the gravity, right? This gravity will do not change, right? Like so I use which example? Water, right? Waters. Sometimes we drink it, so the value is small. So the water's gravity sometimes change, right? But for the concrete, for the building, building they had use this type of the concrete. This type of grade of a concrete, they had the density, they had the volume. This volume do not change with the time. So the gravity of the buildings will roughly be there. So the gravity is the permanent actions, like here. And for, so we just need to remember the permanent actions do not change with the time. It's okay. It's okay. In line, can you see some load is a permanent action? Gravity definitely is the permanent action, right? What else? It's hard, right? I just think the permanent gravity always be the permanent action. Okay, later, let me to some material that I can see this on the next class to let you know. Gravity, right? Load. And for the variable actions, just like the photos, look at here, it will change. Yeah, for the variable action, that the load will vary with the time. Yeah, will change with the time. So for here, the vehicles pass through the bridge. Yeah, the load we will know, right? For a bridge, I just use a beam to represent bridge, right? This permanent, the vehicle card, this time, T, it at here. The next time, they will move to here, right? They move on the bridge. Means the load will change with the time. Do not with the magnitude, also with the varied with the place, right? Place. We can see here, we can regard this type load as a variable load or variable action. Right? Yeah, variable action. Yeah. We know for building, right? Buildings, the top high buildings, they will suffer from the wind load. Yeah, wind load. We use the velocity, right? Wind velocity. Sometimes they will change. So wind load, also variable load, belong to variable load. Okay? For wind load, when we talk about tall buildings, consider the wind load also important in the design. Yeah, and some special load like earthquake. Yeah, for earthquake, what the capture of this type of the load, like usually of the short duration, but significant magnitude. Also, we can think, we can regard the earthquake is the variable action, right? But what's special of the earthquake is it happened in short duration, really quick. Yeah, maybe just half of an hour, right? It happened and then ends the earthquake. What else? Like tsunami, right? Tsunami. Some buildings near the sea side, right? Seaside is in the sea. Sometimes they have a tsunami. Because why it happened tsunami? And also the earthquake, right? The sea quake happened, like caused the tsunami. They applied on the buildings. It also can regard as accident action. Also, what else is like explosion. Some now we use some gas in the house, right? But if really do not careful, the gas blew, explosion happened. For this load, this action, they happened in really short time, right? Short time, explosion, happened. And this impact applied to the buildings will cause typhoon. Yeah, typhoon also can regard as an accident action. Yeah, typhoon. Yeah, this summer, right? This summer, we do not receive the news about typhoon hit Wenzhou. Yeah, it's a little site. Because sometimes typhoons come, and we do not need to go to school. But now, yes, typhoons do not need to Wenzhou. Yeah, it's okay. Typhoon is a very good example to last year accident action. Yes. Do you have any question? different type of the action. Later we will use some different coefficients. Yeah, because for permanent load always be there, so we need to consider that. Right? We need to always consider the permanent load. For variable actions, for one variable action here is okay. If there's a several variation, they work together. Do we need to consider all of the variable action? Yeah, sometimes it's unnecessary. So here we will use some partial factors. Yeah, in the design, yeah, in the structure design. So accident actions definitely be like that. If we need to consider this really significant magnitude, yeah, it will waste. It will be waste. Okay, you get my point? Yeah, because now here we roughly know when we design structure for the load, like action, right? Load action should be smaller than the resistance for structure. I forget how to spell that resistance, but resistance means resistance. Resistance action, right? Action for in our basic mind, only the structure has a strong resistance to bear the load, then we can think that the building is safe, right? Safe. But for the accident action, sometimes the load is the action, the magnitude is really high. If we want to keep the building safe, so we need to have to build a structure has a resistance at this level. That means sometimes maybe we design the section is 200 and 200 is enough, but in order to satisfy the accident load, sometimes we need to build the section like 400. So use this one, they may be waste, right? So it's unnecessary. We just consider the possibility. They can be considered possibility, and you put a factor considered in the whole design process. And just keep, if this magnitude, the load happened, these buildings can have the time for people to run away. Yeah, that things will be okay. Right? We do not need to consider all of the load. We just keep people's safety. Yeah, safety. Yeah, things will be okay. Yeah. So here's we classify. Yeah, we just have a small summary. The action for their origin, we divide direct and indirect. The spatial variation, fixed or free, the nature and the response of the static and the dynamic. Dynamic sometimes connect with variations action because it varies with time. For static, just like gravity, it always be there, do not change with the time. So some behavior we see is on the static load or the dynamic load. Fixed like the furniture we always put here, do not change with the place. Fixed. Yes, green. Here is the effect of the action. Resistance. How we to withstand actions without mechanics failing. For a material, because there's the molecules connect together, so there has an internal force for the material to resist the load. Yeah. So for resistance here, proposed here, just this character of the things that can withstand action. Yeah, what the action that I introduced before. So now, yeah, I ask the question: do you think how you think the resistance related to? So in your mind, yeah. Now just we just discussed. Okay, here. Do you think the resistance will related to what? To you get my point? Yeah. Do you think? Yeah. Do you think which things will related to the resistance for a structure member? Yeah. So do you think? Yeah, this is the resistance. Yeah, I propose here. Yeah, propose here. And now I just ask. Yeah, do you think? Yeah, do you think? Yeah, how you think? Just which things will related to the structure's resistance? Material. Yeah, material. Material, like sometimes we use wood, sometimes we use some steel. Yeah, these things will be totally different. For steel, for the metal, they of course have a highly resistant, right? Higher resistance. For wood, they may break easily. Yeah, material will related to the resistance. And what else? Structure design method. Yes. Yeah, I can explain. Because sometimes we use a hinge, the supported boundary, something, so it can't to bear the moment, right? But we change. If we change the boundary, like here, we fixed the boundary, fixed the type, the design method, something. So for this member, it can to resist moment. So we may think this member has a higher resistance because it can resist moment. Yeah. So due to the boundary different structure type, yeah, of course will affect resistance. And what else? Just this topic, just a talk that we can discuss. Material, structure type. Yeah, before I mentioned the cross section, right? Just like a beam, a smaller section, they had a smaller stiffness. Of course, it had a lower resistance. If a beam had a bigger, a larger, right? A larger section, yeah, of course, it had a stronger. Just a thinner person, we think we push the thinner person, they may easily, but for fat like me, you hard to pull me, right? So the section of the it's also affect, right? Affect the resistance. Okay. Here I just relative factor, material, the geometric dimension, computational mode. Yeah. Here, I just like, because in reality, sometime before we use the hand calculation, so the compute mode will be roughly. So here we will be careful, right? Careful. So sometimes we under evaluate, not, So here we know is the development of the computer. We can refine the models, and it can help us to realize more things. Yeah, more things. Yeah, this is something related to resistance. Okay. And another important concept that we need maybe a design reference period. Yeah. This is a chosen period of time because for buildings, we may see the gravity permanent load, but actually, right, with the times goes, then something happens with the buildings. It will grow, and it will something happen. But for us to design, they of course has a time limit, time for it can work for to reach to at 5 years later in this period it's working. It will be okay for buildings, right? So and of course during our design, the accident load happen, right? May like typhoon. This summer, this year, do not hit Guangzhou, but the last year, they may happen. So there is a period we just think we need to propose a standard period for us to do the calculation or to do the analysis. Here is about the concept of design reference period for us to consider. We can promise like in the later 50 years, the structures, the load, the accident load, or the variable load, or variation load that we consider. And if it exceeds this period, we just sorry, we do not consider that. Just I can use an example. In the 100 years ago, right? 100 years ago, people design like bridge. They will do not consider nowadays the heavy vehicles, right? Because in 100 years ago, the vehicle may do not invent, or they do not consider like vehicles can be normal like these days. Right? Yeah. So they have limitations for different stage persons. Yeah. So they consider the things totally different. Like just like now, we may think, oh, the plane is only fly in the sky, right? Maybe 100 years later, yeah, the plane can just drive in the street. The load will be totally different, right? So, yeah. Here, maybe using this example is not correct, but here I just use this thing that you know. With time, different time, the load considered will, of course, definitely different. So what we can see is that in others' mind during that period, and this load that we can consider the load grows several years later, but will not change very different, right? So here must have a design reference period for us. Yeah, for the buildings, we always generally think the 50 years, and the design reference period. And for this time, yeah, for the 15 years, I hope everyone need to remember it will be attached by the exam. Okay? Yeah, you can write down or in some place, and then in the end for structure, there's a basic requirement of the structure. Basic requirement. The first thing is the safety. Right? We do not hope always the buildings be there or will not broke, but it should keep people living in the building be safe, right? That's the purpose of the buildings. The requirement should keep safety or about the resistance. We do the design the resistance should keep the safety. And so visibility. So visibility means it can provide a function like for people live or for we have the meetings in the buildings, they can ask the serviceability. Do not have, if we live in the building, the building has always has a vibration or survey, people will feel uncomfortable, right? So we need to make sure that the building has its own function. Yeah, and so durability. Yeah, durability means it can't build today and work the next day because we pay lots of resources to build them. It should have durability. This is the things for structure design. And during its intended life, sustain all action and influences. Yeah. Sustain. Yeah. This is remain feet for its requirement. Yeah, this thing is the basic requirement. Okay, basic requirement. We know we have we can realize that things will be okay. And if one day your student or when you go to one place, the other guy asks you, when you design structure, what the basic things you considered? What the basic requirements that you consider? You can answer it. You can tell him, yeah, you considered here the safety of the durability. Yeah, that's okay. That will be okay. Just to let you know, there is a really that make you different because you learned this course, right? You need to show others that different with the normal persons. You should academic words something. So to tell him what it counts and how it works. Yeah, the final will be like so. These things that you need to consider during the learning, and you need them. And for these things, for during the intended life, that you can tell the other guys that you consider during structure design that you know these things. And look at this still happens in Europe, right? There's a famous buildings, but fairs occur. So now the parent branch they collect some information, the design case to repair the buildings. Yeah, this is the explosion, the accident action. For some the human errors for buildings, we design during design. There's a balance, just a balance of fitness, purpose, and the economy. This balance should be good and the worth of the engineer. now here is a reliability. Reliability. What's the meaning of the reliability? The ability structure to fulfill the special requirements during the design working life. Right? For general building design working life is 50 years. Right? During, and had been designed around. For the concept of the reliability. Now we learned action, resistance, and reliability. And during the design process, the reliability always expressed in the probabilistic terms, right? Because for the accident actions, we cannot to contain this really significant magnitude load. So here we just use a probability theory in the design. So here we relate it to reliability. Okay. And there is about how to do the calculation. And we will mention something, but be simple, right? Simple is linear. Do not like there is a non-linear curve. We used to use linear line to briefly to see. But for the basic concept that you need to remember, reliability. Yeah. For the design working life, right? Design working life. For generally the important building is 50, right? 50 years. But for some, sometimes it's also unnecessary. Right? For some temporary structures, we do not consider the 50 years. For this temporary structure, 50 years is too long.